Hello, this is Dr. Brown. In this video, we're going to cover simple and compound interest. This is on page 201 to 204 in your textbook. We're first going to talk about simple interest. When we talk about simple interest, we want to talk about the principle in financial formulas as a balance upon which interest is paid. Okay, you might give the bank $1,000 and you might get a certain percentage per year. That would be called the principal. The simple interest is interest paid only on the original amount and not on any interest added at later dates. So we're going to first start off with the formula. The interest is the principal times the rate times the time. I is the simple interest. P is your principal that you start off with. R is your rate, and it must be in decimal form. And T is the time in years. Do a very simple example. Terry wants to buy a used truck. He borrows $7,650 from the bank. If the interest rate is 9% for 4 years, how much interest will he pay? The interest per year is simply going to be 0.09 times the principal, which is $7,650, is equal to $688.50. For 4 years, the total interest is equal to 4 times 688.50, which is equal to $2,754. Another example, Craig borrowed $1,399 from his parents to buy a stereo. His parents charged him 3% simple interest for 2 years. How much interest did he pay his parents? The per year interest is 0.03 times $1,399 equals $41.97 per year, and then multiplying that times the time for 2 years, the total equals 2 times 41.97, which is equal to $83.94. Suppose Rachel or anyone invested $5,000 in a savings account that earned 4% simple interest. If she kept the money in the account for 50 months, how much interest did she pay? That's just simply she earns 4% divided by 12 per month. That's the interest rate per month, which is 0.04 divided by 12. So the total interest is the principal times the rate times the time. In this case, we're going to be talking about the time is going to be 50 months. That's why we had to get the interest rate per month into the equation. So the principal is 5,000. The rate is 0.04 divided by 12. And the time is 50 months. Multiplying all this out, and you get $833.33 is the amount of interest you will make over a period of 50 months. Okay, in the next problem, Chris wants to invest $7,200 in a savings account that pays 1.6%, and it's only simple interest. So it's not going to be compounded. How long will it take for this investment to double in value? So we'll have to, he needs to earn $7,200 in order to double his investment. The interest then needs to be equal to the principal times the rate times the time. And the principal is $7,200, and the rate is 0.016 per year. And let's work this out in months. We'll divide that by 12 and multiply by t, which is the time, in months now. And that needs to be $7,200. And we need to solve this equation. And one of the first things I would do here is cancel out 7,200 on each side. And we get a very simple equation that 0.016 t divided by 12 equals 1. So cross multiplying, we get 0.016 t equal 12. And so t is equal to 12 divided by 0.016. And that is equal to 750 months. And so that's the answer in months. In years, it's going to be 750 divided by 12 equals 62 and a half years. So if you're only getting simple interest and the interest rate's pretty low, takes you quite a long time to double your money. If it was compounded, the answer would be different. Another problem, how much would you need to deposit in an account now in order to have $37.50 in the account in 10 years? So we're going to let X equal the amount deposited. Or that could also be called the principal amount earned per year is equal to 0.02 times X. In 10 years, you will have 10 times 0.02X equal 0.2X. So if he starts off with X and then in 10 years has 0.2X, we want the total amount to be $3,750. So we get 1.2X equal 3,750, and X is going to be 3,750 divided by 1.2 equals 31.25 is how much he needs to deposit so that it will grow to 3,750 in 10 years. Okay, all of this has been simple interest. I'm going to show you an example or give you a proposition to give you an idea of the power of compounding and exponential growth. Now, everybody probably has heard of Bill Gates. He was the CEO and founder of Microsoft. Right now, he is doing all kind of philanthropical work. In fact, he has decided to give away essentially most of the billions that he's earned over the years. And Bill Gates needs you to work for him for 31 days. He's going to give you two options. Option one, he'll pay you a flat $200,000 for the month's work. Option two, you have the option of getting a penny for the first day, 2 pennies the second day, 4 pennies the third day, and then double the pay each day until you have been paid for 31 days. Think carefully about the option you should choose. A lot of people might say, I'm just going to take the $200,000 and run. But let's see what happens if you actually double the amount each day. Let's look at week one. First day, you get paid a penny. By second day, you're 2 cents, then 4 cents, 8 cents, 16 cents, 32 cents. The seventh day, end of the first week, you make 64 cents on the seventh day. And of course, you can add all this up, and that will be the total for the week, which is roughly You can add it up a little over $1. Week 2, on day 8, you make $1.28. Finally, you keep doubling that, and on the 14th day, you have made $81.92 for that day. And then, of course, you can add all that up to see what the total will be. Week 3, you on the first day of week 3, you make $163.84. Finally, on the 21st day, you make $10,485.76. This total is still a good bit less than the 200,000. But look what happens on week 4. You keep doubling. The first day of week 4, you make $20,971. And finally, on the 28th day of the month, you make $1,342,177 on the 28th day. In fact, on the 26th day, you make $335,000, which is a good bit more than the $200,000 he was going to pay you for the full month. Finally, the last 3 days, you keep doubling it, and finally, holy moly, on the 31st day, you make $10,737,418.23. And you add all this up, you can go do that. You've made probably 20-something million dollars. Now, this is called exponential growth. And this same concept drives what we call compound interest. So when something grows like 2 to the nth power, where n is the exponent, things are growing very quickly. And that's the basis of compound interest. Now, let's look at the compound interest formula. We've got the concept here of what I call future value, or the accumulated balance after T years, and the present value, which is the starting principal, and I generally call it the principal, the present value. R is the annual percentage rate, has a decimal. T is the number of years, and N is the number of compounding periods per year. It could be compounded annually, which means that N is equal to 1. It could be compounded semi-annually, which means N equal to 2. It could be quarterly, which makes N equal 4. Monthly makes it N equal 12. And daily, N equals 365. Notice when you're talking about the rate, you'll have to divide the rate by N, and then, but you're going to have an exponent that is NT. So this is a formula you're going to need to be able to use to calculate future values. Okay, the first example for compound interest, we're going to suppose that you invest $15,000 at 12% interest, compounded monthly. What would your account balance be in 20 years? Okay, we want to calculate then using this formula future value equal present value times 1 plus r over n to the nt power. So the future value is what we want to find. The present value is $15,000. The rate is 12%, which needs to be expressed as 0.12. And the time is 20 years. And the compounding period is monthly, which means n is equal to 12. So we need to write down the future value equals the present value, which is 15,000. To substitute in the formula, times 1 plus 0.112 over 12 to the nt power, which is 12 times 20. Now, this can be done on your calculator, and I suggest that you use a TI-30 XS multi-view calculator. I'm going to clear everything out. I'm going to clear the key press history, and we want to put this equation in the calculator. So we want to calculate 15,000 and you need to use parentheses. 1 plus 0.12 divided by 12. In parentheses, and now you need the exponent, and since you're going to multiply 12 times 20, use parentheses there so that it knows what the exponent will be. Of course, this is going to end up being 240, and then hit the right arrow to bring the cursor down, and then hit enter. And you get $163,388, and round it off to the nearest cent would be 30 cents. So here are all the keystrokes you need to do. And so the answer, as we said, is 163,388.30 is the amount you would have in 20 years if you invested simply $15,000 and it got compounded monthly. Suppose you receive this on a quarterly basis instead of a monthly basis. Here again, you want to find out the future value. It's $15,000 is your principal or present value. The rate is 0.12. Time is 20 years. But N is 4. So you got basically the same formula except a different compounding period. So it's 15,000 times 1 plus 0.12 divided by 4 to the 4 times 20 years. Now, put this in the calculator. And I suggest that you have your calculator available as we go through all this. We're going to clear it out again, and we're going to do 15,000 times parentheses 1 plus 0.12 divided by 4 in this case, in parentheses, and we're going to have to raise that to, well, you could just multiply 4 times 20 and get 80, or if you want to let the calculator do it, do 4 times 20. And then I move the cursor to the right and hit enter. And I get $159,613.36. So if you only compounded it quarterly, you would get somewhat less, but still a pretty good sum. 159,613.36 rounded. Now, we're going to show what would you do if you wanted to figure out what the starting value would be in order to have a certain amount in so many years. Here you're going to use a different formula, and I actually want to show you how that formula would be changed. In fact, remember the future value equal the present value times 1 plus r over n to the nt. If we want to solve for present value, if I multiply both sides by 1 plus r over n to the minus nt, notice we have 1 plus r to the plus nt times 1 plus r to the minus nt gives you 1 plus r over n to the 0. Remember, you add exponents. This is just 1. So we get PV is equal to FV times 1 plus r over n to the minus nt. So I want to show you that very quickly. Now I'm going to erase this and just use that formula, and you'll be able to have that formula available on your test, and also when you do your homework. So now let's do this one. The future value now is what we already want to be $4,200. The present value we want to find out using this formula. The rate is 1.9%, which is 0.019. The time is for 13 years. And it's compounded monthly, so N is 12. So now we should write down PV equals 4,200 times 1 plus R, which is 0.019, divided by 12 to the minus NT, which is minus 12 times 13. And put this in your calculator. And I'm going to also do this with the on-screen calculator just to show you how to handle the negative exponent. I'm going to clear the keys here, clear this, and the present value is going to be equal to 4,200 times the parentheses 1 plus 0.019 divided by 12 in parentheses. And now we need to raise this to the minus 12 times 13 power. So I'm going to use the parentheses. And now that you need to use this negative sign right here at the bottom, not the subtraction sign. We're multiplying by a negative number, not minus 1 times 12 times 13 in parentheses, and then I'll move the cursor over. I'm going to hit enter, and the amount is going to be $3,281.43, rounded to the nearest cent. So the answer to this is $3,281.43. And that is the video on simple and compound interest. I recommend that you go and do the homework and give me a call or email if you have any questions.